We'll start. We'll start with the Omkaram.
Yeah.
Okay.
गणानां त्वा गणपतिगुं हवामहे कविं कवीनामुपमश्रवस्तमम् ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पदान शृण्वन्नोतिभिः सीदसादनं प्रणो देवी सरजिनीवती दीनामवित्र्यवतो गणेशाय नमः सरस्वत्यै नमः श्रीगुरुभ्यो नमः हरिः ओम् Sai Ram.
Sai Ram, everyone.
Yeah. We have today Sister Vanaja who will be taking the session.
Sai Ram, ma'am.
Sai Ram. Kindly mute others. Please mute yourself. And she's been in the SSVV fold for quite some time, and she's been a content writer for science in some of the in the past, and now she has come forward to willingly take the nuances in science teaching, and especially in chemistry, which is her forte. And please do ask your doubts and how to handle a science class session, and take it the way forward to your thing. Over to you, Vanaja ma'am.
Sai Ram to everyone. My humble pranams to the lotus feet of Swami. I am grateful to him for giving me this opportunity to interact with you all through this session for our mutual benefit. Please treat me as one among you and respond. Please keep a paper and a pen or pencil ready. For most of us, chemistry is a mystery. It is full of formulas, symbols, and equations. This is because the concepts are not properly understood, or there may be some gaps in our understanding. Every concept of chemistry has a logic and a sequence. Once we are familiar with them, the mystery disappears and the chemistry becomes more and more enjoyable. With this introduction, I'll start today's session. Pallavi, will you please show the title slide?
Yes, Sai Ram, just one moment.
Yeah.
Beta, come here.
So as you can see in this slide, today I'm going to talk about acids, bases, and neutral substances. I have taken this topic because acids and bases in CBSE is introduced in Standard 7. Standard 8 and Standard 9 have metals and nonmetals and types of chemical reaction. Standard 10 again has acids and bases. Since acids and bases reactions involve metals and nonmetals, it also involves types of reactions. I thought this topic would be beneficial to all of us. Now, let us see what substances are called acids. Now, acids are substances whose solutions are sour to taste. Example we have, I have picked up the examples of lime juice and orange juice, mainly because we are familiar with the taste. as we frequently sip a glass of lime water or a cup of lime juice or a glass of lime juice, or we enjoy the orange fruit in season. So if such examples are given, children will be able to connect it to whatever they're experiencing on a daily basis. When we go to base, in a layman's language, bases are substances whose solutions are slippery to touch and bitter to taste. Now, again, the examples that I have selected is soap solution and of course, bitter gourd. Bitter gourd means Karela. Now, again, these are, soap solution, if you talk about, we everyday experience. We drop the soap on the, wet soap on the floor and we struggle to pick it up as it slips away from our hands quite often. And it's a Herculean task to put it up again, pull it up, take it up again. And bitter gourd is very famous for its bitter taste. The neutral substances are neither acidic nor basic. Again, I am taking the examples of water and common salt. Water, it's used every time. Common salt is used every day. So again, what I'm trying to tell you is that whenever you pick the examples, whenever you select the examples, at least in introductory part, select examples in such a way that they would be easily able to connect it and recognize it in their everyday life. Pallavi, acids and bases and neutral substances, slide, please. Yeah, thank you. We can go through. Acids are substances whose solutions are sour to taste. Examples, lemon juice and orange juice. Bases are substances whose solutions are slippery to touch and bitter to taste. Example, soap solution and bitter gourd. Neutral substances are neither acidic nor basic. Example, water and common salt. I'll talk about acids first. Acids, what do we mean by acid and what are the reactions? And then we will talk about what are bases, what are the reactions, and then probably you will be in a better position to compare in what aspects acid and bases are similar and in what respect acid and base differ. Now, when we talk about acids, there are two types of acids. One is the natural acids. Natural acids are obtained from natural sources. And the second type of acid is called mineral acid. Mineral acids are man-made acids using minerals obtained from the earth. Examples of natural acids, you can think of many. Citric acid that is present in lemon and oranges. Ascorbic acid present in amla and guava. Tartaric acid present in tamarind. Oxalic acid present in tomatoes. Acetic acid or vinegar is produced naturally during fermentation of fruits. Sour milk or curd contains lactic acid. And mineral acids are man-made acids. You can think of hydrochloric acid, sulfuric acid, phosphoric acid, nitric acid, so on. Pallavi, the types of acid slide. Next slide, please. Yeah. Please go to the slide. Now, citric acid is present in lemon and oranges. Citric acid and ascorbic acid present in amla and guava. They contain vitamin C, which is essential to develop body resistance. Then tartaric acid is present in tamarind. Oxalic acid is present in tomatoes. Acetic acid or vinegar is produced naturally during fermentation of fruits. We use it as a preservative. Sour milk or curd contains lactic acid. Lactic acid is a high source or a very good source for B2 vitamin, B12 vitamin and calcium. And mineral acids, examples, I said that they are man-made and they contain, they are examples, what we normally can think of is hydrochloric acid. sulfuric acid, and nitric acid, phosphoric acid, and so on. Now, I just want you to pay attention to the mineral acids. Now, what is the difference you can find from the formula of hydrochloric acid and sulfuric acid? Can anybody please? Any volunteer? Please look. Yeah.
Hydrochloric acid serum, ma'am.
Hydrochloric acid.
Only combination of hydrogen and chlorine, but sulfuric acid is sulfur hydrogen, and here
Sulfur and-
oxygen is 4 molecules, and phosphoric acid is hydrogen 3 molecules, and phosphorus and oxygen.
Thank you. Very good answer. Now, that means HCl, that is hydrochloric acid, contains only 2 elements, that is hydrogen and chlorine. Sulfuric acid contains 3 elements, hydrogen, sulfur, and oxygen. Now, sulfuric acid, the formula shows it contains 4 oxygen molecules. So the acids that contain oxygen are called oxyacids. So sulfuric acid is an oxyacid. How about nitric acid? Is it an oxyacid? Nitric acid, is it an oxyacid?
Phosphoric acid.
Phosphoric acid is an oxyacid. Nitric acid, the formula is HNO3.
Yes.
So HNO3 is also an oxyacid. Now, let us try to find the properties of acids. Now, all acids in water dissociate. When we say dissociate, we mean disassociate. That means they break up in solution. Acids break up in solution to form a proton, that is H+. This proton is hydrated to form hydronium ion or H3O+. Pallavi, next slide, will you please project? Yeah. If you see the slide, can you all see the slide?
Yes, ma'am.
Yes,
ma'am. Yes,
If you see the slide, you can see HCl, if you take HCl in water, dissociate to form H+ ion and Cl- ion. The H+ ion so formed is surrounded by water. So it attaches itself to water and form H3O+. H3O+ is called hydronium ion, like your ammonium ion. H3O+ is called the hydronium ion. And finally, if you see the equation, HCl plus H2O, that is hydrochloric acid plus water, gives hydronium ion plus Cl- ion. What is it called? How is a Cl- ion called?
Chloride.
Is it a chlorine or a chloride?
Chloride, ma'am.
Chloride. Chloride
It's
ion.
chloride, ma'am. It's chloride.
Chloride. See, if it in the normal atomic state, it is called chlorine. In the ionic state, it is called chloride.
Chloride.
Yeah.
Hydrogen hydride like this.
Yeah, binary, like, so
Yes.
this is Cl plus H2O plus gives H3O plus Cl minus. Now you see the equation at the top, HCl plus H2O giving rise to H3O plus Cl minus. Now, if you observe the water molecule, you have 2 hydrogens and 1 oxygen on the reactant side. On the product side, you have 3 hydrogens and 1 oxygen. That means, how did H2O become H3O? What have we added?
Because
For
hydrogen,
H2O to become
hydronium,
H2O, what did we add? What should be added? What is, see, you are having H2O on the reactant side, right? Can you all see? And on the product side, you have H3O plus. So reactant side, you are having 2 hydrogens. On the product side, you are having 3 hydrogens. That means what is extra with hydronium ion?
Adding the hydronium ion.
Hydrogen extra.
Hydronium ion, madam.
In
Hydronium ion.
what is it?
From dissociation of acids. H plus
Dissociation of
ion.
acid. You see the dissociation of acid. H plus HCl plus H2O giving H3O plus plus Cl minus ion. H2O has become H3O plus. Can you see that? Now, like your algebraic equation, what have we done to H2O? We have added a proton or a H plus. H2O, we have already seen that H2O plus H plus gives H3O plus ion. So, the proton is donated from HCl to water. You can see the red arrow. In the red arrow, it shows that the proton from HCl is donated to water so that you get Cl minus and you get H3O plus. Is it clear? Can you see or any
Yes, ma'am.
doubts you have? Is the equation
No,
clear?
ma'am, it's clear. It's
Clear,
clear,
ma'am.
ma'am,
Okay.
no doubt.
It's clear, ma'am.
So that means the acid, HCl is an acid. In solution, HCl is donating a proton to water. So HCl is donating a proton. That means it is a proton donor. Proton donors are called acids. So here HCl is an acid because it is donating a proton to water. Is it clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now all the reactions of acids are due to the presence of H plus ions in solution. So whenever we talk about reactions of acid, it indicates that the reactions are due to the presence of H plus ions in solution. So now let us see one by one what reactions.
Convenient.
Are you ready? So when active metals like magnesium, sodium react with acid solutions, it liberates hydrogen forming metallic salt. That is, when an acid reacts with active metals in solution, it liberates hydrogen forming metallic salt. We can write the statement in the form of an equation. Metal plus acid will give you metallic salt plus hydrogen, or magnesium plus hydrochloric acid will give you magnesium chloride plus hydrogen. Now this reaction is used to test the presence of hydrogen as the gas burns with a pop sound when burning splitter is brought near the gas. Pallavi, a slide please. Yeah. Can you see the slide? Metal plus acid gives metallic salt plus hydrogen. Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Now here what gas is evolved? Any answers? What is the gas that is evolved?
Hydrogen gas.
Hydrogen gas. Hydrogen gas.
It's a hydrogen gas, ma'am.
Test the presence.
Hydrogen.
We are going to test the presence of hydrogen. How are we going to test? If you bring a burning splinter near the hydrogen gas, it burns with the pop sound. So if it burns with the pop sound, then we can confirm that it is the gas that is given out is hydrogen. Now, this is an example for a particular type of reaction. Can you tell
Displacement,
me what? Yes?
displacement reaction, madam.
Displacement? Will you please check once again? I'll show the equations, then probably you'll be able to tell me better. Next slide, please, Pallavi. Now I have given the equations.
It's displacement reaction, ma'am.
Okay.
Ma'am, it's
Now,
a displacement reaction because hydrogen atom is displaced.
hydrogen atom is displaced by which atom?
Magnesium, higher active metal. Active metals, ma'am.
Okay, thank you. Good answer. Now, I just want you to tell me one thing. Why did we write Mg? Why can't we write Mg2? Like O2, I write
Diatomic.
oxygen, I write O2. Why can't I write Mg as Mg2?
Monoatomic.
Monoatomic, diatomic.
Very good answer. Metals are all monoatomic. Therefore, in the element state, they'll have one atom. So the symbol for magnesium, the formula, the symbol for magnesium is Mg. Now, can you follow the equation? Can you follow the equations? Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Is the equation balanced? Will you please check?
No, madam. 2 MgCl.
2 MgCl. 2.
Yes.
2 mg.
All of you, I told you to keep a paper and pen ready. No? Please work out the equation and tell me whether it is balanced, please.
Yes,
Ma'am,
ma'am.
2 mg.
It's not
Already
balanced.
balanced, no, ma'am. Already it was balanced.
Balanced, ma'am.
It is balanced, madam.
Balanced, ma'am.
It is balanced, ma'am.
It is balanced only, ma'am.
Ma'am.
Reactants are formed in
Available.
reactants that you have 1 mg.
Balanced equation, ma'am.
Do you all agree that it is a balanced equation?
Yes, ma'am. It's balanced.
Yes, ma'am.
Yes.
What about the next? What about the aluminum reaction?
Balanced, ma'am.
Reaction balanced.
Aluminum reaction also balanced.
It is also balanced equation only.
Yeah,
Okay, how
second
about
one
the
is
third
also
reaction?
balanced.
How about the third reaction?
All are balanced equations only, ma'am.
Okay. Now, the third example we are using sulfuric acid. So the product formed will be the salt of sulfuric acid, right? That is why getting zinc sulfate. Suppose in case of sulfuric acid, I use nitric acid. What will be the salt formed?
Nitrate.
It will be zinc nitrate.
Zinc
So
nitrate.
the salts of nitric acid are called nitrates. Now, how are we going to test the presence of hydrogen? How can we confirm that hydrogen gas is given out?
By
If
Cox
we
sound.
By the pop sound.
Bringing some fire near that evolving gas.
By burning splitter near that, the gas will continue to burn
Pop
with a
sound.
pop sound. So that will confirm the presence of the gas that is given
Hydrogen
out.
gas.
Okay. Very good response. Thank you for your responses. Now let us see. We have seen how it reacts with metals. Now we will see how it reacts with metallic oxides. Now can you guess the products? What will happen when metallic oxide reacts with acid solution? Can you please write out on the paper and let me know?
salt and
Salt and
water.
Salt and water, ma'am.
Salt
Salt
and
and water.
It forms the salt and water.
Very good
Yeah.
response. Yeah. So metallic oxide plus acid will give you metallic salt plus water. Okay. Now can you do this with an example? You take your own example. Any metallic oxide example. Sodium oxide or magnesium oxide. You take any acid and just try out the reaction, please. And let me know.
when sodium
Magnesium oxide plus
oxide reacts with
Calcium oxide plus 2HCl.
magnesium oxide plus HCl, madam.
Sodium oxide.
Yeah,
What is
calcium
the formula
oxide.
for sodium oxide?
Magnesium oxide plus hydrochloric acid forms magnesium chloride plus water.
Okay,
Yeah.
fine.
The same way calcium oxide.
Sodium oxide. What is the formula for sodium oxide? Pallavi, next.
Sodium oxide plus HCl gives rise to sodium chloride and water.
Sodium
NaCl
chloride
plus
and water.
What is the formula for sodium oxide is what I asked.
Na2O. Na2O.
Why is it Na2O? Can you tell me?
Sodium is a monoatomic.
Yes, ma'am.
Sodium, we don't, the atomicity doesn't count. For sodium, the valence is 1.
Atomicity of
Oxygen,
sodium
the
is 2.
valence
Oxygen
is
is
2.
1.
Okay.
2 and 1. Valence of
Pallavi,
oxygen is 2.
Valence of oxygen is 2, sodium is 1, so it will be Na2O. Okay, good job. Yeah. Pallavi, next slide, please.
This slide is okay, Vanaja ma'am? Or next after this?
Next one, next one.
Okay, okay.
That Na2O, it comes, no, that one.
This is correct?
No, not this one. I'm sorry, Amma, the previous one. I'm sorry.
Okay.
Because I was looking at my system. So, yeah. No, even before that, you will get sodium carbonate. Sodium oxide, Na2O. Yeah, this is the reaction. Yeah.
This is the slide you want? This slide is okay?
Yeah, yeah.
Okay.
This is the one. So, will you please check your answers with the reactions on this slide, please? If you have you all got the same one?
Yeah, I got the copper chloride one.
Okay, thank you. Good job. Shall we proceed to the next one? Are you all comfortable?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Okay, thank you. Thank you. Thank you. Now let us see how acids react with carbon and bicarbonate.
Sairam, everyone else, please mute your mics. Thank you.
Yeah. Now let us see how metal carbonates and bicarbonates react with dilute acid. Okay, here again I want to ask you, what is the difference between metal carbonate and metal bicarbonate?
Metal carbonate having CO3 as functional group, hydrocarbonate HCO3.
HCO3.
Can you tell me with the charges? What is the charge on carbon carbonate and the charge on bicarbonate?
-1.
In case of carbonate, it is CO3 2 minus, and in case of bicarbonate, it is HCO3 minus.
HCO3 minus.
For carbonate, it is CO3 2 minus.
CO3 2
For
minus.
bicarbonate, it is
NO3
minus. Then, bicarbonate and hydrogen carbonate, are they both the same, or is there any difference? Sodium bicarbonate and sodium hydrogen carbonate, are they the same?
Same, madam.
Yes, ma'am, they are same.
They are
Same, ma'am.
Okay, then fine, thank you. So, can you guess the products? Yes. Can you guess the products? Metal carbonates react with dilute acid?
Ma'am, water plus carbon.
Metal carbonate, how
Corresponding metal salt with the liberation of carbon dioxide and water.
So, do you mean to say that?
No, ma'am, it gives corresponding metallic salt with the liberation of carbon dioxide and water.
Carbon dioxide and water.
Can you please mute yourself?
So, metal carbonates, when they react with dilute acid, you get metallic salt plus carbon dioxide plus water. Very good, thank you. And how about the bicarbonates? Will you please?
Bicarbonate also gives same products, ma'am.
Ma'am, it's
Same
both are
products
same.
will get?
Yeah.
Okay. So we can we conclude that metal carbonates and bicarbonates react with dilute acid to give the corresponding salt, liberate carbon dioxide along with water. Can we conclude that way? Can we conclude?
Yes, ma'am.
Yes,
Okay, we can conclude that metal carbonates and bicarbonates react with dilute acids to form metallic salt plus carbon dioxide plus water. Pallavi, next slide, please. What we have said that has been represented in this slide. You can check it up yourself whether what you have said and what you have understood are correct, are the same. Sorry, sure that it coincides with your way of thinking?
Yeah, ma'am, it's the same.
Okay, thank you.
Yes, ma'am.
Okay,
Yes.
thank you. Now, how are we going to conclude that the gas that is coming out is carbon dioxide?
With the help of lime water test.
Okay,
Lime water
Yeah,
test.
ma'am. Lime water test. We can test.
Tell me how it is formed.
Lime water will turn
Carbonated
into
lime
bubbling
water, the
water.
lime water, it becomes milky.
Yeah.
Milky white.
It
What
turns
will
into
happen if
milky.
you pass excess of carbon dioxide?
It forms corresponding
Will the
bicarbonate.
milkiness
Carbonate.
stay or increase or
Bicarbonate.
decrease?
Metal
forms-
What will happen
bicarbonate.
to the milkiness?
That is in case of excess.
What will happen to the milkiness?
Formation of carbonates.
Formation of
No.
carbonates, ma'am.
The milkiness, will it stay or disappear, increase, decrease is what I'm asking.
Soluble in water means white precipitates.
Soluble means you won't get the precipitate, right? You'll get in the solution,
No,
right?
with the soluble we get bicarbonate.
Oh, bicarbonate, yes.
Okay, fine. Next slide, please, Pallavi. Yeah. Now, you can see here, sodium carbonate plus HCl gives sodium chloride plus water plus carbon dioxide. That is what you say. And you have even said the valencies of carbonate and bicarbonate correctly. So I'm happy about it. And then what I want you to observe and appreciate is that the way the equation has been written. Are you able to understand me? Now, if you see here, it is written, see there, it is written sodium carbonate S within brackets. What does that S indicate?
A solid.
Very good. S indicates the solid. That is, it represents the physical state of sodium carbonate. So how are we using the sodium carbonate? We are using the sodium carbonate not in solution form, but we are using it in the solid form. So we're taking some sodium carbonate salt, and then to that we are adding HCl. Now, why it is mentioned HCl aqueous?
Solution, ma'am.
Hydrogen ion.
What is the difference between HCl and HCl aqueous? Can anybody tell me?
Solvent is water. Solvent is water. Aqueous means
what is the basic difference? See, if I write HCl and HCl aqueous, do both mean the same?
HCl aqueous means we dissolved HCl in water.
What
we
is
dissolved HCl in
what
water.
Is what is HCl when you are dissolving in water?
Dissociation of HCl takes place.
I mean, you are dissolving hydrochloric acid in water.
Is diluting.
We are diluting.
Diluting HCl.
Just here, please listen. Just one clarification here. HCl, when we don't write aqueous, it generally means hydrogen chloride gas. Okay. So when we write HCl aqueous, it means HCl in acid form. So that is why always you have to mention it is in solution, or you have to write aqueous. The purpose of writing aqueous is that it is in the acid form as hydrochloric acid, not as hydrogen chloride. Both have the same formula. Like NaCl is sodium chloride, HCl also is hydrogen chloride. So we can't deny that, right? So when HCl is dissolved in water, what you get is hydrochloric acid. So it is mentioned there aqueous. Then sodium chloride aqueous means where it is You have got sodium chloride, you have got water. So where will you find sodium chloride? Is my question clear to you?
It is in dissolved condition.
The sodium chloride so formed is dissolved in water and is appearing as sodium chloride solution. The solution that is left over contains sodium chloride and it is liberating carbon dioxide in the gaseous state. So whenever an equation has to be properly written, the physical states have to be mentioned. Please ensure that you train your children to mention the physical state, because normally when they by heart, most of the students by heart the equations, we all know that it is not correct. So by looking at the equation, the entire story of that equation has to be brought out. Now, the equation very clearly says that sodium carbonate has been taken in the solid form. To that, we have added hydrochloric acid, that is aqueous HCl. The product formed is sodium chloride, that is in water. So, the leftover liquid in the test tube will be sodium chloride solution, and it is liberating carbon dioxide gas. Similarly, when we are talking about sodium hydrogen carbonate or sodium bicarbonate, the same thing here also. Sodium chloride will be obtained in solution along with water, or sodium chloride formed is dissolved in water and appear as sodium chloride solution, and it will be liberating carbon dioxide gas. And same thing we have done with calcium carbonate, and they have taken magnesium bicarbonate also as an example, just to give you the practice. So always insist wherever possible, the equation has to be completely, fully representing the reaction that is taking place. Suppose there is heating, normally on the arrow we put the triangle sign that indicates there is heat. If there is a precipitate, we put the arrow downwards. If it is gas, we put the arrow upwards. So all that basic symbols have to be properly represented in a proper equation, because by looking at the equation, the entire reaction is expected to come to their mind. Am I clear? Is it clear to everybody?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes, ma'am.
Now you already told me how to test for carbon dioxide. So
Saira, ma'am. Saira, ma'am, I have to know.
Yeah.
Ma'am, while writing the equations, actually the polyatomic groups, they have valency, if you take CO3 having -2 valency.
Okay.
How they're calculated, ma'am? If we for elements with the help of electronic configuration, now okay, we can tell valency.
Okay, very good question. See, what happens is we do it by oxidation numbers. We calculate it using oxidation numbers. Have you gone through how calculation of oxidation numbers?
Ma'am, please give an example, ma'am.
I'll do it after I finish this class, okay? I'll definitely do it. Okay?
Okay, ma'am.
I'll show you, okay? Yeah. Now, so going back to the lesson, the reaction between, you only said that metal carbonate with dilute HCl. Pallavi, next slide, please. Sorry. So, metal carbonate and dilute acid, you get carbon dioxide, and this carbon dioxide, when it is passed through lime water is a solution of calcium hydroxide. It produces milkiness due to the formation of insoluble calcium carbonate. So calcium hydroxide plus CO2 gives calcium carbonate plus water. The milkiness disappears when excess of carbon dioxide is passed due to the formation of soluble calcium bicarbonate. Can I have the next slide, Pallavi, please? You can see the reaction here. When carbon dioxide is passed through lime water, it turns milky due to the formation of an insoluble precipitate of calcium carbonate. The following reaction takes place. Calcium hydroxide plus carbon dioxide gives calcium carbonate plus water in the liquid state. Calcium carbonate is in the solid state. That implies it is in the precipitate form. So where the calcium hydroxide is lime water, the calcium carbonate precipitate causes the milkiness. The milkiness is due to the formation of calcium carbonate, which is insoluble in water. So it produces the milkiness. If you pass excessive carbon dioxide through lime water, the calcium carbonate reacts with excessive carbon dioxide and water to form calcium hydrogen carbonate or calcium bicarbonate. Calcium bicarbonate is soluble in water and thus the milkiness dissolves in water. That equation is also given. So are you all familiar with this equation?
Yes, ma'am.
You know this equation, you made the statement, so I assume that you know the equations too.
Yes, ma'am.
Okay, thank you. Now, next slide, Pallavi. Electrical conductivity. We know that acids conduct electricity. In general, electrical conductivity.
Ions.
Ions.
Presence of ions.
Ions.
Very good. But is there anything else? Yeah, I mean, only ions are responsible for. I'm not talking about acid. I'm talking in general. In general, only ions will conduct electricity, or something else will also conduct.
Electrons, madam.
Electron. So, what is common between electron and ions?
Charges, madam.
Charges.
Having positive or negative charge.
Oh, that means electrical conductivity is due to the presence of charges. Charges, which is a charged particles. Okay.
Charges.
Okay. Pallavi, next slide. So, electrical conductivity is due to the presence of charged species. Acids in solution conduct electricity due to the presence of ions. If ions are not formed, they will not be able to conduct electricity. That is why we always say acids in solution. Okay. Now, let us talk about acidic oxides. The oxides of non-metals are acidic in nature as they produce acids when they dissolve in water. So since they produce acid and dissolve in water, these oxides are called acidic oxides. One example is when carbon dioxide gas is dissolved in water, we get carbonic acid. This carbonic acid is nothing but soda, and most of the soft drinks contain this dissolved carbon dioxide. Is it clear?
Yes, ma'am.
Now somebody was asking me about the valency of carbonate, right?
Yes, ma'am.
Yeah, you see the formula for H2CO3? Okay.
No, ma'am. What I'm asking for CO3, we have.
Please let me get back to you. Let me try to understand what you want, then you can talk. I just want you to look at the formula for H2CO3, right? Yes. Okay. So the CO3 radical is combining with how many hydrogen ions? Hydrogens?
2.
2. What is the charge of H plus?
1, 1.
1, 1. So how many positive charges are there? For each hydrogen, there is 1 positive charge. For 2 hydrogens, there are 2 positive charges. Okay?
Yes.
So H2CO3 is electrically neutral. There is no charge. Yes or no? H2CO3 is neutral, right? There is no charge on H2CO3. If H2 is plus 2, if H2 contributes 2 positive charges, how many charges CO3 should contribute?
Minus.
Minus? Please mute. Yeah. Now please understand and then you can ask.
If it is neutral, both should carry one minus.
If it is neutral, Look at the formula for H2CO3. Okay. Each hydrogen is +1. So 2 hydrogens will contribute +2. So since H2CO3 is neutral, CO3 should have -2 charges. That's it. Okay.
CO3, like
CO3
-2.
That is what I'm
Having
telling you.
valence, for polyatomic groups. Okay, NO3 like NH4 we having.
We call carbonate as a radical. Okay, whatever in our time, in our term. See, you look at H2CO3. Okay. Now I'll give you a simple example. You take HCl. Okay. H is +1, Cl is -1. Agreed?
Yes, ma'am.
Same way you for H2CO3.
Ma'am, like for CO3 we have -2 valence, like how they're calculated. What is the process? Just
Process is that is what I'm saying. Normally for radicals, acid radicals, they are calculated from the easiest way to understand is to see how many valence is combining capacity. Yes or no?
Yes, ma'am.
So carbonate ion is combining with 2 hydrogen atoms, 2 hydrogens. So what is the combining capacity of carbon CO3 CO3 radical? -2. Because this is +2, that has to be -2. Understood? You try the same thing with sulfate also. Sulfate SO4 will be 2- because it is having 2 hydrogens. Okay. If it is still not clear, we'll talk about it later. Okay. Yeah. Are you clear or not? Now you tell me, sir.
Ma'am, what you told that one clear, but CO3 how it got -2 that. For CO3
when you split H2CO3, you will get 2H plus CO3 2- because H2CO3 is electrically neutral. You just combine it with HCl, you get the idea. HCl is H plus and Cl minus. H2CO3 is 2H plus CO3 2-.
not only in case of CO3, not only in case of CO3, but
in everything,
polyatomic groups.
In everything.
Polyatomic.
In everything, it takes sulfuric acid. Okay. It
Yes.
takes sulfuric acid is H2SO4 H2SO4. So SO4's combining capacity is 2 hydrogens. So each hydrogen is +1. So 2 hydrogens is +2, SO4 is -2. It is the same. You can try any acid. Otherwise, I'll calculate later 1-to-1. Okay, let us. I can do it. I mean, I think you understood it. You try and then get back to me. Since you have my number, you can post immediately by Insta. Okay? Yes. Okay. Can you know your name?
Prabhavati, ma'am. Prabhavati.
Okay.
No,
Okay.
Prabhavati.
Prabhavati, yes. You can go. If it's still not clear, we'll correspond 1-to-1 and see that it is clarified. Okay? Even based on objection numbers, we can do it. Okay. Okay, now, so far we are. Please mute, please.
Sairam, please mute. Otherwise, ma'am cannot talk. Sairam, thank you.
Yeah. See, so far we have seen some reactions of acids. Now let us talk about bases. Now, as I have already told you, solutions of bases are soapy to touch, and they have a bitter taste. Some examples of common bases you must be knowing: bathing soap, washing soap, toothpaste. Toothpaste is also basic. That is why when we are brushing it, to remove the acid particles that get stuck in our teeth, in between our teeth, we use the toothpaste so that the acidity is getting neutralized. Then, of course, antacid to reduce acidity when our digestive system develops more acid. So these are all some examples of common bases. Now, we also have bases in nature. Most vegetables and most non-citrus fruits are basic in nature. And we also have metal oxides that are basic in nature as they react with acids to form salt and water. Now, this point is very, very important. Soluble metal oxides or soluble bases are called alkalis. So there's a difference between alkali and base. If the base is soluble in water, then it is called an alkali. Example, sodium oxide.
Water soluble base.
1 minute. Let me just, I'll show you the slide, I'll clarify. Okay. Sodium oxide plus water gives sodium hydroxide. The general statement is all alkalis are bases, but not all bases are alkalis. Since not all metal oxides are soluble in water. Pallavi, present this slide, no, please. Pallavi, next slide. Yeah.
This one is okay?
Yeah. I'm just reading it out. Wherever your doubt is, you can ask me. Solutions of bases are soapy substances with bitter taste. Some examples of common bases are bathing soap, washing soap, toothpaste, antacid. Most vegetables and most non-citrus fruits are basic in nature. Metal oxides are basic in nature as they react with acids to form salt and water. Soluble metal oxides or soluble bases are called alkalis. Example, sodium oxide, a metal oxide, dissolves in water to give sodium hydroxide, NaOH, which is an alkali. Na2O plus H2O giving 2 NaOH. This is the equation form. All alkalis are bases, but not all bases are alkalis, since not all metal oxides are soluble in water. Any doubts? You take, for example, copper oxide. Copper oxide does not dissolve in water. So, though copper oxide is a base, it cannot be an alkali. That is what it means. Clear?
Yes.
Okay. Now, let us talk about the properties of bases. Metals react with basic solution to form any gases?
Hydrogen gas only.
Liberate hydrogen gas, and what they will form? What will be the other product?
Salt.
Okay. Okay.
Metallic salt.
Okay. Suppose if sodium metal, if sodium hydroxide, what is the name of the salt?
Basics.
If zinc reacts with sodium hydroxide, can you predict the name of the salt?
Sodium zincate. Sodium zincate.
Sodium zincate. Very good. Pallavi, can you show the slide? Properties of bases. Next slide, please. Yeah. You can see the reaction. Now, again, here you can see the zinc is in the solid state. Zinc is a metal, therefore, element, it is monoatomic. We have written only zinc. Sodium hydroxide, it is written aqueous, means it is sodium hydroxide solution. You can see on the arrow heat, that is how the equation has to be written. That means zinc on reaction with sodium hydroxide, and on heating the solution, we get sodium zincate in solution and it liberates hydrogen gas. Is it clear? This is how the equation needs to be represented. Now they have also given for dilute HCl just for comparison. Now both are giving salt and water. But what is the difference? Can you tell me? We look at the equation.
Like
Yes,
in
please.
first equation, it is consuming energy.
How do you say it is consuming energy? We never talked about any energy.
No, heat.
So what is happening? Zinc will react with sodium hydroxide on heating, whereas zinc will react with dilute HCl on cold condition or without heating. So This is where the difference between an acid and base normally come across. The conditions of the reactions, there will be slight variation. Basically, both give almost the same products. Both are giving salt. Both are giving salt and both are giving hydrogen. Both the salt, sodium zincate is soluble in water. Zinc chloride is also soluble in water. But then, and it is also liberating hydrogen. But then, the reaction between zinc and base takes place on heating, whereas zinc and HCl acid does not, takes place at room temperature. There is no need to heat. Now, there are some metal oxides like aluminum oxide, zinc oxide. They react with sodium hydroxide to produce salt and water. Now, we said metal oxides are basic. Sodium hydroxide is also a basic. It's also a base. So, we normally do not expect base and base to react. But there are certain exceptions where base reacts with base. So, is my explanation clear to you? Normally, we say that metal oxides are basic. So, all basic oxides will react with acid. All non-metallic oxide will react with base. But then, there are few metal oxides. As I said, like zinc oxide, then aluminum oxide. They all react with bases also. Again, they'll form salt and water. Can you project the next slide, Pallavi? Yeah, you can see here. Zinc oxide is a metal oxide. Sodium hydroxide is an alkali or base. Both of them react to form salt and water. Then tin oxide, again, sodium stannate and water. Aluminum oxide, sodium aluminate and water. That means zinc oxide, tin oxide and aluminum oxide can react with both acid and base. Do you agree?
Yes, ma'am.
Okay. What are such oxides called? Do anybody know that? Does anybody?
Amphoteric oxide.
Very good answer. Very good answer. Such oxides that have both the properties of acid or base that such oxides that react with both acid and base are called amphoteric oxides. So we have acetic oxide, we have basic oxide, we have amphoteric oxide. Acetic oxide example is, can you tell? I want fast the reply.
CO2, SO2.
CO2, SO2, right. Basic oxide, sodium oxide. Then amphoteric oxide, aluminum oxide,
aluminum.
Tin oxide, zinc oxide, lead oxide.
Okay, okay. Thank you. Now, like acids, the bases will also dissolve in water to produce ions. So, when sodium hydroxide dissociates, you will be getting sodium oxide plus hydroxide or hydroxyl ions in solution. So, can it conduct electricity?
Yes, ma'am.
Yes. You have heard, you come across electrolysis of sodium hydroxide. So, electrolysis of sodium hydroxide is an example to show that sodium hydroxide conducts electricity. So, since the primary requirement to conduct electricity is the presence of charged particles, and sodium hydroxide in solution produces charged particles or ions, sodium hydroxide in solution will also conduct electricity just like acids. Is it clear? So it is there is a similarity here. Both acid and base will conduct electricity in aqueous solutions or in a solution state. Now the next reaction that we are going to talk about is neutralization. So neutralization reactions normally take place between acid and base. So normally acid and base will react with each other to form salt and water. This is very characteristic of nuclear reaction. Whenever acid reacts with base, the products are always fixed, that will be getting salt and water. The common example we can think of is sodium hydroxide, when it reacts with hydrochloric acid, you'll be getting sodium. Now, can anybody tell me why this reaction is called a neutralization reaction? I said when an acid reacts with a base, you get salt and water, and this reaction is called a neutralization reaction. Can
Both
anybody
acid
get?
and base, both acid and base will lose their characteristic to form a salt.
So, salt, what is the state of the salt?
Neutral in nature. Neutral.
Okay.
Neutral.
Okay.
Without any ions, it's
Very appropriate answer. Now, when the acid and base neutralize each other, the products formed are neither acidic nor basic. Therefore, such reactions are called neutralization reaction. Next slide, please. Pallavi. Yeah, you can see the reaction. The solutions of bases dissociate in water to form ions. NaOH in solution will dissociate to give Na plus OH minus ions in solution. Therefore, soluble bases conduct electricity due to the presence of ions. Second one is neutralization reaction. Acids and bases in solution react with each other to form salt and water. Hydrochloric acid plus sodium chloride solution will give you sodium chloride plus water, sodium chloride plus water. Obviously, sodium chloride will dissolve in water and you'll be getting sodium chloride in solution itself. This reaction is called neutralization reaction because acids and bases neutralize each other and the products are neither acidic nor basic. Now look at the last reaction. This is again an important reaction. H plus plus Cl minus, that is HCl, I have written in the ionic form, H plus Cl minus. Sodium hydroxide I have written in ionic form, Na plus OH minus. When they are combined, they'll give you NaCl plus H2O. Okay. Can you tell me what is happening between H plus and OH minus? Because Na plus is remaining as it is, Cl minus is also remaining as it is. Both of them combine to give NaCl. But what is happening between H plus and OH minus?
Oxidation.
Is it oxidation? Why it is oxidation? If you name it oxidation, why is it called an oxidation reaction? Now,
it is becoming neutral means.
Understood.
Actually,
I'm not denying that water is neutral. My question is
actually OH minus having more electrons is giving to H plus. Then
I'm not talking about any electron. I have not represented any electron here. Have I represented any
combination, madam?
I am not representing any electron. I just want you to observe the reaction, and if you can find out a solution to what I asked, you can please come forward.
H plus is receiving oxygen. H plus is receiving oxygen. That is the oxidation reaction. Hydrogen is receiving oxygen.
Will you please be clear? What is taking what? Who is giving? Who is taking?
Hydrogen is taking the oxygen. That is this oxidation reaction.
Hydrogen is not taking oxygen. It's do you present it that way? Now, what is the
H plus is a proton. H plus is a proton. Here OH minus. Here, yes, ma'am. Combining, we are finding attraction. No, what we call? Yes,
So
ma'am. Attraction. Accepting a proton.
If I am donating, what should the other person do?
Receive.
Receive.
Yes. Yes.
What do you say? Can you find a better term? Receiving is okay. They are
accepting.
Accepting. H plus is donating a proton. OH minus is accepting the proton.
Yes.
So we already decided HCl is donating a proton, so it is an acid. bases are accepting the proton. So bases are all proton acceptors. Is it clear? Please.
Yes,
All of you, please check if your mic is on mute.
Okay. So now is it clear? If somebody is donating, there has to be somebody to accept. So when proton is, when HCl is donating a proton, we already know HCl is a acid, so it is a proton donor. So the H plus donated by HCl is being accepted graciously by OH minus to form water. So always remember, bases are proton acceptors, acids are proton donors. This is the basic concept. Beyond that, this concept is also an old concept. After that, we have got many more concepts of acids and bases. But for the present, for the syllabus or for your requirement, it is sufficient to know that acids are proton donors, bases are proton acceptors. Acid will always donate a proton. When somebody donates a proton, somebody else should be willing to accept the proton. Otherwise, the donation goes a waste. So here H plus is donating a proton, OH minus is readily accepting the proton. That is how neutralization takes place. So neutralization is generally the reaction between H plus and OH minus to form water. H plus is proton donation, OH minus is proton acceptance. So proton donor, proton donation and proton acceptance are the basic reactions of neutralization. Is it clear? Is it clear?
Yes,
Ready?
ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Okay, Pallavi, the next line. Now the same reaction, it is actually a double replacement reaction. You can see it is self-explanatory. Do you agree that it is double replacement or double, what do you call, what is the other name for replacement? What is the type of reaction called? Double displacement. Double displacement. Or double displacement. Okay. Now, can I have your attention, please? Now, I thought that I would cover only up to this, that is acids and bases, and then stop here with neutralization reaction, because I want to know how well the information given by me has been absorbed by you. So I've got few quiz questions. So let us see. Either you can do it here or you can do it later and post it in the group. Pallavi, that last but one slide.
Yes, just one moment.
Yeah. So these are the questions, and I'm sure you'll be able to do it. You want to try it now, or you'll do it later?
You can see, right, ma'am? You can see?
I mean, others must be able to see. Otherwise,
Yes,
we can put them in the group if they can't see.
Sairam, everyone can see the last slide, recapitulation?
Yes, ma'am, we can see.
Yes, ma'am. Yes, ma'am.
Okay, thank you.
Do you want to try the answers now, or you'll do it later?
Pallavi, if you can you just copy paste these questions in the chat box? So people can start giving the answers in the chat box.
Shubha sister, let them post the answers later, right? Because they may have to think.
Yeah, but somewhere they should note down, no, ma'am. So that's why I said.
Yeah,
chat
let them
box.
note down. Let them note down. Yeah.
Or teachers, you can just take a screenshot of this one and then you can post your answers in the group. Pallavi, is this the last slide?
The last, this is the last
Yes,
slide.
Saira. Last.
Okay.
So if they copy the questions, then we can ask them if they want any further clarifications.